Welcome to solverfy.
Okay, so here we're describing an algorithm that'll find our repeating integers in a list, right? So let's just go ahead and call this procedure repeated, something that explains what it does. And this procedure will take in a list of integers, so up to some n number of integers. I'm just gonna shorten integers to ints here. And of course, this will only work if there's at least one element in the list, right? So we need n to be greater than or equal to 1. And so this w slash just means with. Additionally, it is a non-decreasing list. So a1 must be less than or equal to a2, which must be less than or equal to a3, which must be less than or equal to a4, and so on. So these are the stipulations we have, and since we are creating a list of these numbers, we're going to initialize an empty set that we can add to. Additionally, we're going to create an n plus 1th element to our list, right? So we'll set a n plus 1 equal to a n, so this last element in the list, but we're going to subtract 1 from it, so it's less than that. So don't be confused. Here, n plus 1 is a subscript, but then the an, just the n is the subscript, and we're subtracting it. And so this, by creating this last element, we do that due to the comparisons we're going to make. So while investigating any element, we're going to compare it to both the previous and next element in the list, right? So we have our list of things here. The problem is once we get to the last element in the list, there ends up not being anything for us to compare it to. Okay, so we're initialized, so we're just sort of creating something there that will pass our test. In an appropriate way. Okay, so now that we've initialized these elements, we're going to run through the list, right? So for I, and it's going to actually start at the second index, right? And it does that because, again, we're comparing to the previous items in the list. So we're going to start at a2, and it's going to run all the way to n. And if the element we're currently investigating is equal to the previous one, right? So that's just checking to see if we currently have a 2. We're just saying, hey, is the thing before it also a 2? Okay, but that's not quite enough, because if we had 3 2s, if all we did was check the previous one, we'd be adding 2 to our list of repeated elements twice, right? Both at the second time it occurs and at the third time it occurs. So to make sure we only add it to our list once, we also want to check whether or not the next item is larger. Okay, so we represent that by saying AI is less than AI plus 1. Right, and this is why we had to do this initialization here in the second step. And if those both hold, then we want to add the element in question to our list, right? So we'll take the list and set it equal to itself, whatever is currently in there, plus AI. And then finally, we want to return our list. We want to see all the things that are repeated in our list that we submitted into this algorithm. So we want to return S, and that will complete